Geometry 7-4, parallel lines and proportional parts. We're going to start with a theorem here, triangle proportionality theorem. In this triangle proportionality theorem, if I have a triangle that looks something like this, this is triangle ACD, and I have another side in here, and these two are parallel to one another, and this one is going to be BE. Then, and we've seen this already in 7-3, but we're going to talk about it more pointedly here. I know that angle B and angle C are congruent, and I know that angle E and angle D are congruent, and I know that because I have parallel lines, and this is a transversal that goes through those parallel lines, and so is this, and so these angles here are congruent based on our knowledge of a transversal and parallel lines. So these are consecutive angles, right? Consecutive. And they are corresponding angles in our triangle. So here we go. Triangle ABE is similar to triangle ACD. Oops, triangle. And this is by the angle postulate. All right. Now, let's say AB, side AB over side BC. So this is looking a little bit different than we've done before. Before we said the little piece and the big piece. Now we're going to say one piece and the other piece. So AB over BC equals this piece AE over ED. So we did an example in 7-3 where we looked at something like AB over BC and AE over AD. Now we're looking at AB over BC. Did I say? Okay, so BC and then AE over ED. So we're looking at this piece and this piece, this piece and this piece, instead of this piece and the whole thing, this piece and the whole thing. So this looks a little bit different, still good. The inverse is true. So if AB over BC equals AE over ED, then ABE, triangle ABE is similar to triangle ACD. All right. Now, find the side length. So here's your example. We'll do this one together, then we'll do a U-try. We have a triangle. Looks like this. We've got these guys that are parallel to one another. This is triangle PQR, and this here point is T, and this vertex is S. PS is X. SR is 2.5. PT is 7.5, and TQ is 3. So we are going to use our new proportions that we just learned to find our side length. We want PS, and that's the only side length we need. Okay, we're going to look for PS. So that's this one here, that's x. And so what we can do here is we can say x over 2.5 equals 7.5 over 3. So we're going to take the x over 2.5, so we're looking at this one side, and then we're going to do the 7.5 over 3. So notice the smaller pieces are on the bottom and the bigger pieces are on the top. So we're going to try to keep that stuff straight. Now we just do cross products. 6 times 3 is 3x, or sorry, x times 3, not 6 times 3. 25 times 2.5 times 7.5 is 18.75. Divide both sides by 3. X equals 6.25. So PS is 6.25. Okay, let's see if you can do one on your own now. Here's another triangle. We've got these parallel line segments again. We're going to label this the same way, P, T, Q, R, S. Now this time PT is 15, PS is 12.5, SR is 5, and I want to know what is TQ. And so you might want to call this X or Y or A or something like that, so that when you set up your ratio, you've got a variable to solve for. Okay, go. Let's see how you did. All right, so I'm going to use X for TQ, and I'm going to put 12.5 over 5, and I'm going to put 15 over X. And then I am going to cross multiply. 5 times 15 is 50, plus 25, so 75, equals 12.5x. Divide both sides by 12.5. X equals 75 divided by 12.5 is 6. So TQ is 6. I hope you guys got that one right. Now we're going to talk about a mid-segment of a triangle. Mid-segment of a triangle. Okay, and so for this part, I'm going to have you just write down this mess here for the mid-segment of a triangle, so you don't have to wait for me to write everything out. So draw a big triangle, and then draw a little triangle underneath it, or inside of it, upside down. And then maybe I should just draw this together, shouldn't I? Let's draw it together. So first we're going to draw a big triangle. And this triangle we're going to call A, B, C. And then right in the middle of AC, we're going to put a point, and that's going to be point R. And it's in the middle, so that means AR is congruent to RC. And then right in the middle of AB, I've got point P, and AP is congruent to PB. Now right in the middle of CB, I've got Q. And QB is congruent to QC. Now, I am going to connect these guys, these new points that I made that are in the middle of each of these segments. So the mid segments here of triangle ABC, they are RP, PQ, and QR. Notice a mid-segment is just taking the center point of two of the segments and drawing a line between them, a line segment between them. So we just found the center of AC, the center of AB, we drew a line between those two centers. Same thing with CB, we drew a line segment between all of those points. So that's a mid-segment. Now here's the mid-segment theorem that I am not going to write for you, that I already wrote for you a long time ago before I even knew who you were. Mid-segment theorem, I would like you to write down here. So the triangle mid-segment theorem, a mid-segment is parallel to one side of a triangle. Its length is half the length of that side. Okay, write this down even though it maybe doesn't make any sense to you at all. Then let's look at this triangle down here. So I've got a triangle, and I have the mid-segment right here between the two, and I drew a line. This mid-segment is parallel to the other one, the one that it's not touching. The one that's not touching is the one it's parallel to. So that's what this is saying here. The mid-segment is parallel to one side of the triangle. So it's parallel to this side. And its length, so the length AB, is half of the length CD. Or 2 times AB, 2 of this, are one of these. And AB is parallel to CD. All right, let's see if we can do some examples based on our new knowledge of mid-segments. All right. Find each measure. So let's draw a triangle. Big side here, big triangle there, side there, and a big side. So we're drawing this nice big fat triangle. This is triangle ABC. Now, right here in the middle of AB, I have a point, and that is point D. Right in the middle of CB, I have point E, and right in the middle of AC, I have point F. So I have a line from D to E and a line from F to E, or line segment. Okay, now AD is congruent to DB. EB is congruent to CE, and CF is congruent to AF. I did 3 there. Should be only 1, 3. Okay. AC is 15. And this angle right here is 82 degrees. FE is 9.2. And that is all the information I have to give you. Now I want to know, what is DE, what is DB, and what is the measure of angle FED. All right, so this is an example we're going to do. Oh man, I don't have any. Well, I've got a couple U tries. Okay. So DE is this one here. So this mid-segment, I know it's a mid-segment because these two are equal, so these two cut those in half. So this is a mid-segment. This mid-segment is parallel to this side, and it's half of this side. So I know 15 over 2 is going to get me what DE is. This side divided by 2 is going to get me DE. So 15 divided by 2 is 7.5. So DE is 7.5. Now let's find DB. Okay, here's DB right here. All right, so how are we going to find out what DB is? We got to think about this for a minute. I want to know what this length is. Now, I have this piece of information right here. This is the mid-segment that is parallel to this side. This mid-segment is also half of this side. So if I were to multiply 9.2 by 2, I would get AB. So that would be 18.4. And then I want to cut this side in half, because DB is half of AB. So really what I'm saying is this 9.2 is the same as this. This length is the same as this length, because this length is half of AB and FE is half of AB. Interesting. So 9.2 is dB. dB is 9.2. Now let's find the angle of FED. Where's FED? FED. That's this angle right here. Okay, so now I've got this segment is parallel to this segment. And now I have alternate interior angles. Alternate interior angles are congruent. So 8.2. If the lines are parallel, then the alternate interior angles off of this transversal are congruent, 82 degrees. All right. Proportional parts of parallel lines. Proportional parts of parallel lines. Okay. Whew, proportions. Super fun. All right, we're going to draw 3 parallel lines. And then we're going to draw a transversal this way and a transversal this way. And we're going to mark that these lines are parallel to one another. Okay, this is going to be point A, B, C, and then we've got point E, F, and G. So those are our points. So we're going to write a little statement about this. If AE is parallel to BF is parallel to CG. So we're just talking about these segments. We could say they're lines too if we wanted to, but we're talking about this segment right here. So if these are all parallel, then AB, so AB here, over BC is equal to EF over FG. All right, now let's see, I have an example that I didn't like from last time, and I didn't realize that I had that example ready to go here. Right. So I'm going to make one up real quick. All right, so here's an example. And I've got 3 parallel lines. And I've got 2 transversals here that go like that. So this is going to be J, K, L, and this will be M, P, Q. Okay, so now JK is 5, MP is 6, KL is X, and PQ is, let's say 12. Okay, so I want to know what X equals, which is KL. So what I'm going to do is I'm going to use this proportion here to find out. So I know that this over this equals this over this. So let's do that. 5 over X equals 6 over 12. So now I'm going to cross multiply. 6 times X is 6X. 5 times 12 is 60. Divide both sides by 6. X equals 10. And there you have the proportional parts of parallel lines. One last bit here before we are done with 7-4 is example / U-try, who knows? I think, we've got two. We've got an example and a U-try. Here is a big right triangle. Oh, I got two U-tries here. Oh, they're all hiding. Okay, example. So I've got a right triangle. I've got a mid-segment. These two sides are congruent. This section is 2x plus 1. This section is 3x minus 5. I want to know what x equals. Okay, so for this example, I've got these two triangles that are similar. This triangle is similar to this big triangle here because I know that that this angle is the same, and I know that this is a right triangle as well because this side is parallel to this side since this is a mid-segment here. So this is going to be 90 degrees as well. Now, let's see, how can I find what x is here? Now notice, if this is 90 degrees, and this is a mid-segment, or this cuts this segment in half, I'm not told that this is a mid-segment here, that this segment is a mid-segment. But I can deduce that that is because this is 90 degrees, and so these are parallel. I think I said that backwards before. So anyway, here we are. These two are parallel because these are 90 degrees. And if these are parallel, then these are going to be congruent. Because I wasn't being told that there was a mid-segment, even though I said that kind of at the beginning. This is why I know it's a mid-segment. Okay, since this is a mid-segment, then I know that this segment is congruent to this segment. So I can say 2x plus 1 equals 3x minus 5. I can subtract 2x from each side. I'm going to add 5 to each side. 2x's go away, 5's go away. I end up with 6 equals x. X equals 6. Okay, now I've got two for you to do on your own. I've got a 3 parallel lines. And I've got this segment here is 8, this segment here is 8. I want to know what x equals. This segment here is 7x minus 2, and this segment here is 4x plus 3. So that's one U-try, and then I'm going to give you the other U-try, and then have you pause so you can get this done. Okay, these are parallel lines. This is A, B, C, D, E, all the way around. AC is 14, BC is 8, and AD is 21. So I want to know what is the measure of ED. All right. There are your two U-tries. Go ahead and pause and get to work on those two. Go. Okay, let's take a look at this one. Now, this one, I don't really need to set up a proportion for this one. I can. It would be 8 over 8 equals 7x minus 2 over 4x plus 3, and I can do cross multiplication there, and I can find my answer. But notice these are both the same, so that means these both have to be the same as well. So I can just say 7x minus 2 equals 4x plus 3. Subtract 4x, add 2, and I get 3x equals 5. Divide by 3, x equals 5/3. Now you should still get 5/3 the other way. If you set up proportions, you should still get 5/3, which is 1.6 barred. So you should, that would be your answer there. All right, let's look at this one now. ED, where's ED? Here, this is what I'm looking for. Okay, so for this one, you could set up the proportion a couple different ways. You could do the piece over the whole, or you could do this piece over this piece equals this piece over this piece, which is more in line with what we're learning in this section. But either way, it doesn't really matter. You should still end up with the same answer. So I'm going to do, since I'm all set up already, I'm going to do the small piece over the big piece equals the small piece over the big piece. So 8/14 equals the small piece ED, I'm just going to call that x, over the big piece, which is 21. Now I'm going to cross multiply. 14x equals 8 times 21. 8 times 21. I'm going to say 8 times 21 like that. And then if I'm going to divide both sides by 14, this is how I do it without a calculator. 14 is 2 times 7, right? And then 8 divided by 2 is 4. 21 divided by 7 is 3. So x equals 4 times 3, which is 12. If you put all that in your calculator, you should still get 12. Either way, it's fine. And that is it for 7-4. Do a good job on your homework.